Hi everybody, it's the Dark Guardsman, and we're back with another video. Now, last video we went ahead and kind of figured out what exactly we're going to do, went over a little bit of detail on the design aspect, not really went into much depth. You can pretty much almost consider that an introduction video and almost completely ignore it if you haven't actually seen it already. So what we're actually going to end up building is an item-based battery box. For those who didn't catch on the last video, what we mean by an item-based battery box is that instead of doing what the most mods do and just make a box that has some kind of energy buffer in it that you connect with wires, has a GUI you can open up, look at the power level, it puts some batteries in the slots to input energy, output energy, stuff like that. Maybe not even get that much. There's a few mods that just simply have a block that has some kind of exterior battery bar, and that's all you get. For what we're going to do, we're going to build a simple tile that acts almost like a chest, but has maybe fewer slots that you just stick batteries in. And then when power is inputted into the chest, it's going to add power to the batteries, and when it's pulled out of the chest, it's going to take those power out of the batteries, effectively allowing the batteries to be our storage. That way we don't need a special storage handle and everything else. Now, that's the concept. Now we got to actually implement it. For implementation, we're going to end up making a block, a tile, and we're going to have to figure out how to wrapper the code to the actual batteries. We already have the battery made, as you can see. The class is right here. The bottom half is used purely for information, and let me undo that real quick because I fumbled with the keyboard. So bottom half is just information. This is the only part that actually is logic, and we get some basic data entry up here just to make sure that we can only stack it once and everything else. So let's go ahead and implement our first bit of code. Now we're going to just implement a basic block here. What we're going to do is, let's see where we're going to put this per se. So we're definitely going to put this in our content package. It doesn't matter how you put it and organize it inside your own mod. You can do whatever you want to do. We're going to keep kind of consistent with how this package structure is set up, and we're just going to make a new package down here, and we're going to call this battery. Because after all, that's what we're making. We're making a battery box. We're going to make a new block class, so we'll call this block battery. And we're going to make a new class for the tile entity. Tile entity battery. Make sure this extends our actual tile entity. Now we're not going to extend the prefabs I have, simply so you guys can see how everything's going down. Plus as well, the prefabs are designed to have that magical battery buffer inside the machine and not actually meant to do what we're doing. We are going to extend the prefab, however, for the block though. So we should have block ICBM. And the reason we're doing this is just kind of simplifies the code just a small amount. We want to make sure we have other things like rotation and other stuff that comes pre-built with the prefab, and I'll go ahead and show that off here in a second. So with the prefab, one, it goes ahead and sets our hardness so we don't forget, sets our registry name, sets our creative tab so we don't have to remember to do that. Make sure that we extend block container. I've heard that this is not the way you want to do it, so theoretically what you're actually supposed to do is just extend block and then implement iTiling provider on your own. But this has a few extra checks in it that does stuff that I extend and kind of like to use, so I have it in here. With the actual rest of the methods in here, this gives us rotation property automatically, so we can actually detect the rotation of our block and use that. But we're just going to use that for the moment. We're not going to add any more properties on this, so our block state just going to be rotation based. We could come in here later and do much more fancier graphics. I doubt we're going to get an opportunity to do that anytime at the moment. This also handles things like block breaking, dropping inventory for us. It does do multi-block code for us. We don't have multi-blocks on our stuff, so we don't have to worry about that. Same thing with this as well. It should drop our inventory for us by default in the super method, I believe. There's code in here somewhere. It's probably like the ondestroyed. That will drop our inventory so we don't have to worry about it. Let's go ahead and set the name. For the name, we're just going to call it battery. So this will be ICBM battery. There's already an item name for this, so let me rethink this here. So let's actually call this battery box. This will lowercase for us automatically. Theoretically, you want to make sure this is always lowercase or put some space in it. For material, I think we're going to do wood. So material.wood. And this does matter what you do pick for the material, because this will change kind of how tools are behaved with your block. In our case, I don't really care if it's harvestable via wood and everything else. There are ways to change this if you want to make it a material wood but then make it harvestable by all tools. There are methods you can override and change that behavior. For this right here, we're just going to make sure we create tile in the battery, and then we're done. We don't really have to do anything else here. We don't need to do any texture work in here or anything else. When it comes to actual textures and stuff, how we're going to handle that is come over to the client proxy, and then we're just going to want to implement an actual block here. And we're just going to copy one of these lines here, and then just make sure that we separate out, and we're going to do battery here. I'm going to leave it its own section, just so that way we actually do have an opportunity. We can come in here later and decide, say we want to make a tiering for our stuff. We can then do what we're doing here and have different tiers for the textures. We are going to need to actually make this variable in ICBM Classic. This would be, if your own mod, this would basically be your mod class if you're copying this in order to add the functionality to your own mod. We're doing this in ICBM Classic because this is where the feature is actually going to implement it at. And we'll do this, block battery. And that'll create our variable so that way this is accessible. We are going to need to register it, or if not, we will crash on launch. So we're going to go ahead and do this down here. And we will have to make an item as well for this. So I'm going to do... Well, actually, we're doing the item right now. I'll do the block in a second. I completely skipped a step there. Just on a note, when you do your stuff, blocks are registered before items. For some reason, I have to set this up a little differently in the class file. And we'll go ahead and do this. It doesn't matter really what the order these are registered in. It basically is first come, first serve. So whatever stuff gets registered is whatever ends up in the queue first. That's something you don't really need to worry about. There we go, that registers our stuff for us. So this will register our block. It'll then put that on the registry and create it basically. Then it'll make an item. If you don't make an item for your block, it will not show up in creative tabs and you can't access. You'll have to create another way to make that block accessible. This is a cool feature if you want to make blocks that are attached to the same item. Say you have like a whole bunch of decorations, you want them to drop as a single item so you don't waste a whole bunch of item IDs, or you have unique types of blocks that spawn purely from, say, like creep growing over them or something like that, but you don't want that to be accessible by the player at any given point. But we're not worried about that. We've got that set up, so we've got our block, we got our item, we actually have our actual item. So we have all this set up. Now we need to get into the actual implementation of the system. Now we're going to need an inventory, so I'm going to use my basic inventory system. There are classes built into Forge to allow you to quickly make an inventory. It's all done through the capability system, but I have my own version of it, which has been around since 1.7. This is the reason why I can use it. It's pretty simple. Basic inventory. And then what we'll do is we'll add our interface, inventory provider. I'm doing this just to get the interfaces really quick. The reality is I don't actually need this anymore. It's pretty much obsolete in my code. But in order for the basic inventory to work properly, I actually end up using it. And actually, I think, do I want to use the basic inventory, or there's actually another one I can use. I think it's called external inventory. Basic inventory can be used for anything in my prefabs, but external inventory is specifically designed for this exact case. I want to go ahead and just return inventory here. If inventory equals null, then we want to make the inventory. Inventory equals new external inventory. And then we'll have some kind of slot capacity. Just go really quickly, public, static, final, and we'll do int slots. And we'll say we want 5 slots. And I can make this configurable later, but we're going to want to make sure we actually have everything set up. And this is one of the things with the external inventory. I need to make sure this is the inventory provider because this is going to actually look for inventory provider. So that's set up. I have my inventory here. I'm going to still need capabilities for this. So we're going to need to implement 2 methods. I'm going to do this really quick to go find the instance of the methods. So we need get capability and we has capability. I'm going to copy these. I'm going to still make sure they return to super just so that way mod support still exists. But what we'll do here is we'll check to see what we're looking for in terms of capability. So it has capability facing, and the get capability. We're going to use this for both the power code and inventory code, and the reason why we're going to implement inventory code on this is so that way you can put a hopper and you can feed batteries into this. It's just going to be something a little extra to put in here. The reality of it is that we're not going to actually get a good usage out of it, to be honest, because you're going to not really be able to have a separation of slots between charge and discharge. If we make another block later that is purely for charging items, then what we could do is implement a really nice solid inventory support. In this case, what we want to do is go if capability equals item, I think actually it's capability item handler, and then we just want to return true. Actually, we want to return if yeah, we'll just return true. Like, something I could do here is go, if my inventory is null, I don't really want to have a capability, but then that'll break pipe connections and stuff, they won't work properly. And then down here, we want to basically just copy this method real quick, put this down here, and instead of returning true, we want to return our get inventory call. And the reason we want to do get inventory is that way it'll call this right here and initialize it. We don't ever want to actually access this, and try to make that a little clearer as you put an underscore in front of it, and that'll help you remember that that's not accessible. And then we can even do something like private, and then it'll basically make sure that anything that extends it can't access it either. And then I also forgot to put the slots down here. I don't know why I typed in a 5 down here when I made the final method. So we got that. We got our inventory code going. Now we're going to need some kind of power going on. In order to do this, one, we're going to make sure that we actually do have a check for this. So capability equals capability energy is what it's called. And this will give you access to the Forge energy system. If you want to use somebody else's energy system, you can go look out their API's design. Most of them are pretty much the same. You have capability access, and then you'll have some kind of capability like energy that you would get a hold of. If you wanted to use somebody else's capability, what you would use is you look for this system right here. You would actually can put this in your own mod, and then you can get access to the interface. That way, if you wanted to program for their API, but you didn't want to have a hard line on their actual capability instance system, you can just use the capability injector to grab it. Additional to this, what you could do is also use a proxy system and then use the on capability assign event, and then use that to actually attach stuff if you want to add things for like IC2 support, RF support, BuiltCraft support, and stuff like that. That way you don't have to have a hard dependency on them, and it should work out really well. Anyways, return true in here as well. And technically what you could do is also do checks right here. Say for example you wanted to turn off energy support, you could do that, which is pointless because this whole purpose is to make a battery function. Of course down here we would actually return some kind of capability. What we would want to do is up here is actually put like energy storage, and this would be we're going to call this a battery wrapper. Now we're going to create this later, and we're going to make sure that we actually have this. And what I'm going to do is I'll make another method exactly like this, and we'll put this as energy storage. And then I need to make sure I fix this right here. I didn't mean to actually rename that method when I was renaming stuff. And we'll make sure we go down here and change that to that. And that probably changed the interface, didn't that? Yeah, this is one of the problems if you're using IntelliJ and you aren't paying attention when you end up refactoring something, is that you accidentally refactor the submethods. Continue. And then this is going to be get energy storage, is what we're going to call this. And then we'll just return this down here. And the reason why we're casting the T is that this is going to expect a return type of T. That return type is going to be your capability. So if we were looking at the energy storage capability, which is right here, that would be an instance of this. So that would basically cast it to that, which is what we already have. It's just one of those weird nuances with auto casting and everything else that you have to kind of just do that. So that should get our energy storage, and then we basically just have to change this method at some point, and I'm just going to make it return a null value at the moment until we get the wrapper up. Now when we do the actual wrapper, which I guess we might as well code at this point, we're literally just going to feed it an inventory, and it's going to get all of our stuff here. Let's try to think of like the best way to handle this. Yeah, there's no easy way to do this, so what we're going to have to do is just make ourselves a brand new system, and this would be... Actually, might be able to reuse this later, but I'll worry about that another time because there's actually other battery slots. This is going to be inventory energy storage is what we're going to call this. And this is going to implement energy storage, and it's going to keep track of an inventory for us, and of course we got to implement all the methods too. So there's going to be a lot of get energy and get max energy in here, and we're going to want to cache these at some point, which means we're also going to want to have some kind of callback in case our inventory updates to make sure we update these two methods. Get energy is something we're probably going to have to just recalculate every single time, so we're going to have to get that. So you know what, we probably could do this for get energy max as well. It won't be too intensive. For those who go like, oh, but you have to for loop every single time, well, the fact is, unless you're getting like 1,000 calls a tick, it's not bad because we're going to have a 5-slot inventory. Even if you had a 100-slot inventory, the performance would be okay. Of course, we're going to make sure we still have the we're going to set these to true because there's nothing you really could do about these. And plus, we just really want to make sure that our stuff just connects. Extract and receive, we're going to do the same way. So we're going to probably end up iterating everything. So we could do a really cool trick that would make this a lot easier to work with. And that would be to implement iterable. If I can spell today. Yeah, right here, iterable, Java lang, and then energy storage. And then we have to implement a method for this. This is going to be a little weird to implement though, because what this effectively does is we got to return an iterator, and our iterator is going to effectively do the work for us, so we don't have to go do a whole bunch of special cat checks and everything else. We don't have to keep rerunning everything else for us. Instead, what we can do is just go, okay, I want to loop over myself, and how this would work is to just really quickly code this for us, and we're going to do int energy equals 0, and we'll return energy. We do have to worry about with this method right here that there is a possibility we could underflow or overflow with this method. I'm not going to show you how to fix that per se, because I'm just going to pray and hope that nobody's ever implemented a battery item that gets close to integer max, or anywhere to the point where a combination of multiple batteries get to integer max. But there's that possibility and risk that that could happen. But with the for loop here, what you would have is energy storage, and then this. You would be able to iterate over yourself, and then you would be able to literally just go energy plus equals storage dot get energy stored, and there you go. That's your method, and the same thing would apply down to here. And instead of doing get energy, you would get max energy. So that's working out pretty well. So this will be basically how we implement the entire thing. Now I'm going to go ahead and pause here as my dog needs to be walked at this point. And this is a good cutoff point to keep these episodes from getting too long. And we'll be back, and I'll show you how to implement the iterator in order to get this going. And at that point, we'll be pretty much close to done, because we only have a little bit of math methods to do, and then actually implement everything else.